In this section, we're talking about probability. Probability is a numerical measure between 0 and 1 that describes the likelihood of an event will occur. So, for example, if we want to know the probability that Ohio State's going to win the national championship, perhaps a month or so ago, we might have said 80%. However, now, obviously, it's 0 because Clemson already won. So the probability that something's not going to occur is equal to 0. So it's not going to happen, probably 0. So probability is never negative, and it's never above 100% or 1. So we have some terms in probability: experiment, outcome, sample space, event. Okay, so when we have an experiment, it's an action that leads to some outcomes. So for example, if we're tossing a coin or rolling a die. So when we list the sample space for tossing a coin, it's listing all possible outcomes, okay? So for tossing a coin, what are your possible outcomes? And we use braces. We can either toss heads or we can toss tails, right? That's our sample space for tossing a coin. Our sample space for rolling a die, what are our possible outcomes? 1, 2, 3, and we have to list them all out. We just don't say 1 through 6. Sorry, it's hard to do with this pen here. 5, 6. So we list the sample space, everything out. Later on, we'll do a probability tree where we can show you how to, when we have more complex experiments, list a sample space. Okay, now, this is how we write a probability statement, probability of A. So if I want to know, and also remember, this means the probabilities fall between 0 and 1. So probability statement means the probability, this means of tossing a coin and getting heads. Okay? It doesn't mean P times H, it means the probability of. Let's say we wanted to find the probability of rolling an even number when we roll a dice. Okay, we put inside our parentheses here what we're trying to find the probability of. Now, in both these cases, we use what is called the equally likely approach or classical approach. So to find the probability, we take the total number of outcomes in A and divide it by the total number of possible outcomes. So in tossing a coin, there's 2 possible outcomes. The number of heads would just be 1 out of 2. Now, we can also write this as a decimal, 0.5, and oftentimes with probabilities, we will talk about them as percents, and that would be 50%. So the probability of tossing an even number, we count how many numbers we have of even. We have a 2, a 4, and a 6. So there's 3 even numbers out of a total possible number of outcomes of 6, which is again 1/2 or 0.5 or 50%. Make sense? Okay, now, if they're not equally likely, we use what's called the relative frequency approach. In this case, they're not as the same chance of getting something is not equal from each one. So, for example, if we're going fishing and we want to know the probability that we catch a bass, right? Well, in my pond, let's say I know that I have 13 bluegill, 17 bass, and 10 catfish. Obviously, I don't really know that, but let's just pretend. So therefore, there's a total of 40 fish. So the probability of catching a bass is how many bass there are, 17. Oops, sorry about that. Out of my total of 40. Make sense? And then the last way we calculate probabilities is the subjective approach. So that's back to, let's say I want to know the probability that OSU wins national championship. Let's say I asked myself a month ago or 2 months ago, I said it was 80%. Make sense? Okay, so when we talk about probabilities, just to recap here, that probabilities always fall between 0 and 1. You don't want to forget that one. Okay?